Welcome. I'd like to talk to you about rationalizing denominators. I want to look at a few examples here, three examples of where we rationalize denominator. What does it mean to rationalize denominator? It means to remove the radical from the denominator. So we have a square root of 5 in the denominator here. We wanted to rewrite this where we do not have a radical in the denominator. How are we going to accomplish that? Well, what you want to do is take this fraction and multiply it by some form of 1. If we multiply any fraction by 1, it's not going to change it. And so what form of 1 do we want to multiply it by? Well, if you look at the denominator, you may notice we have the square root of 5 here. And what could you multiply it by to eliminate the radical? Well, you may have discovered if you multiply square root times itself, then the radical goes away. So we want to multiply numerator and denominator by square root of 5, so we're multiplying by a form of 1. So our original fraction will be equal to this. In numerator, we're going to have 3 square root of 5. In the denominator, we have square root of 5 times square root of 5, which is square root of 25, which simplifies to 5. Okay. And so this expression does not have a radical in the denominator. We start with one that did, so this process is called rationalize the denominator. Now we cannot divide this common 5 here because this is not under radical and this is under radical, and so we're through. Let's look at a second example. Let's say we have square root of 5 over square root of 18. Now we want to rationalize. Well, we could multiply this by square root of 18 over square root of 18. But there's an easier way to do this problem. An easier path to follow is to simplify the denominator before you rationalize. So if you look at square root of 18, you can simplify that. 18 contains a perfect square factor of 9. 18 is the same as 9 times 2. And we can use the product rule to simplify this and write this as the square root of 9 times the square root of 2. And the square root of 9 is 3. So this will be square root of 5 over 3 square root of 2. Now that I've simplified the denominator, I want to rationalize the denominator. Here's the last step. Okay. Well, we have 3 square root of 2 in the denominator. There's a couple of things you could multiply by to rationalize. You could multiply numerator and denominator by 3 square root of 2, but there's something that's a little bit easier. If you just multiply by square root of 2, it'll require less steps. And so if I multiply by square root of 2, it'd be square root of 5 times square root of 2. That's square root of 10. And in the denominator, we have the 3, and then we multiply square root of 2 times square root of 2. That'll be square root of 4, or just 2. So it'll be square root of 10 over 3 times 2, or square root of 10 over 6. And we cannot divide the common 2 here because the 10's under radical and the 6 is not. We'll look at one final example of rationalizing. This time the denominator is a binomial, has 2 terms. Okay, so and how we work this is going to be a little bit different than when the denominator is a monomial, it has 1 term. Again, we want to multiply it by some form of 1, but what form of 1 do we multiply by? Well, if you look between the 2 terms, you see a minus. If you change that to a plus, if it were a plus, we would change it to minus. Then you just write down the 2 terms. Okay. If you multiply by 5 plus square root of 3, that will eliminate the radical in the denominator. Of course, we don't multiply the denominator by that. We need to multiply the numerator by the same thing, so we come up with an equivalent fraction. These 2 binomials actually have a special name. They're called conjugates. When you multiply square roots that are conjugates, it eliminates the radical. Okay. So here I just want to distribute the 2. Multiply 2 times the, well, I'm just going to leave it in factored form. I think looking ahead, it'd be better just leave this as a product. Then in denominator, we have two binomials we want to multiply. What do we use? There's a technique called the FOIL method. Multiply first, outer, inner, and last. So if I multiply the first terms, I get 25. If I multiply the outer terms, I have 5 square root of 3. Multiply the inner terms, I have minus 5 square root of 3. And if I multiply the last terms, let's see, we have a minus and a plus, so the product will be negative. We have square root of 3 times square root of 3, which would be just 3. You may notice that we have plus and minus square root of 5. That would yield 0. And so I have 2 times quantity, 5 plus square root of 3 in the numerator. And I have 25 minus 3 in the denominator, which is 22. And you may notice I left the numerator and as the product of two factors. And the reason I decided to do that was I noticed when I get to this step, we can divide 2, go into 22 11 times. So the final answer is 5 plus square root of 3 all over 11. If you were to put this in the calculator, you would get a decimal. If you would put what we started with in a calculator, you would get the same decimal. That's true for each of these examples. This is square root 3 square root of 5 is equal to 3 square root of 5 over 5. And you could check it with your calculator. Hope this helps. Bye.